Okay, so the dotted line is the curve they gave us, and we're supposed to reposition it so it looks like so it's this after the transformation. So one step that might help is to use actual points here. This point is 0, 0, right? And in function notation, that means f of 0 should equal 0. Now, what if we do this transformation to it? What if we add 1 to that inside? So f of x plus 1, that's now f of 1. And then we still have the minus 2 and a negative sign on the outside. This is going to be a dot on our new graph. F of 1, we can get what that value is off our original graph. So this says look at the original dotted green function and find out what the y value is when x equals 1. So 1 on the x, we have a y value of 1 here. Okay, so I replace that with a 1. And -1 minus 2, that makes -3. What we just found out is if you were to plug in 0 into the original function, you get out -3 in the new function. So 0, and then -1, -2, -3. That's going to be a dot on our new graph. Okay. So we can do that again. Like this is another point on the graph. Let's do something else. Let's do this one. The original function, we have -2, 4. So what we want to know is what's happening with the transformation. If I plug in -2 in for x, what's the new y value going to be? So that's going to be f of -1, because -2 plus 1 makes -1. So f of -1, that's something we can get from our graph. -1 on the x, we have +1 for the y. So subtract those, it makes -3. So when we plug in -2 in for x, we get out -3 for a y value. So -2, 1, 2, -3 should be a dot right here. Okay, so we got 2 dots. That's one way of approaching this problem. Another way of approaching this problem is just by going by the vertical and horizontal shifts. Okay, here's our original function. We're supposed to graph this transformation. If you add 1 directly to x, that means you're shifting the original graph, the entire thing, 1 unit to the left. Okay. And then if you have a -2, that means you're shifting down 2 units. Then the negative sign means that we're supposed to switch directions. Okay, so I think we got to evaluate that first. So we did the +1, that means we move 1 unit to the left. And the negative sign means instead of looking like this, it needs to look like this. Okay, and then this tells us shift down 2 units. So instead of starting at -1 on the x, it should start down here, where it should change to a different function. So there's our sketch, and see those points that we pointed out are lining up here. Okay, so 2 different ways of doing that. The second way is probably a little quicker, but it's a little harder to do. So here's our original graph. At -1, 1, there's a dot. And at 1, 1, there's a dot. And at -2, I think it's 4 on the original graph. I can't put it from Newton on here, but we're supposed to manipulate it by making this transformation. The +4 means we're supposed to take this dotted line, this dotted curve, I should say, and move it 3 units to the left. 4 units to the left. So here's our graph temporarily. We've only done 1 transformation so far. Okay. The ×3 means every y value that comes out of your original function is getting multiplied by 3. So this thing needs to increase faster. For example, in this graph, at 1, 1, if we were to multiply every y value by 3, instead it would look like this, right? Because 1, the y value of 1 times 3 is higher like that. So anytime you see ×3, it should be making it more narrow. It should be increasing faster over a shorter period on the x-axis. So we went 4 to the left. We're getting shifted ×3 in this direction. And then the -3, like we did in the last video, means we're supposed to go down 3 units. Okay, but just like I did in the last video, you want to have Newton make sure it's pointing to specific points that are correct. Okay, so in this original graph, it was at 0, 0. Now this other graph, we shifted it 4 units to the left, 1, 2, 3, 4, and then 3 units down. So this dot needs to be in our Newton graph. It needs to be -4 to the left. So -4 on the x, -3 on the y. And then another dot that should happen is, in the original graph, we climbed by 1 over 1 period on the x-axis, and then by 3 on the next one. So because we're multiplying everything by 3, the next dot here, we have -4, -3, And so negative 3 should be at 0 here. So my sketch is a little off. It should look like this. Okay. And another way you could get that is you could say, okay, well, let's find out what the y value is when I plug in negative 3 in for x, just like we did in the last one. So it's f of. So negative 3 plus 4 makes 1. And to find out what f of 1 is, remember f is the original function. So this means go to 1 on the x-axis. The y value should be 1. So we found out that this is equal to 1. So 3 minus 3 makes 0. So that point right there should definitely be negative 3 on the x, 0 on the y. Okay, so plugging in those values, that's how you're going to figure out exactly what Newton should be pointing to. If Newton has a dot that only lines up on negative 5, plug in negative 5 like I did, find out what it simplifies to be for a y value.